The presenter who was not ready will be rescheduled to present at the end of the session after all other presenters have finished. During other presenter sessions, please mute your microphone unless permitted to speak. Okay, I'd like to remind all presenters to change your display name into uh, your room, followed by paper ID, followed by your full name. And please make sure to use a visual virtual background provided for this session. This helps maintain a consistent and professional appearance throughout the event. Okay, now let me inform you about the presentation order. The first presenter will be Mr. Mario, followed by Mr. Ida Bagus Indra Budi Kusuma, followed by Mr. Jostiman Tatarigan, followed by Mr. Dimitrios Sarafis, and lastly, Mr. Elsam Rafi Saputra. Please make sure you are ready when your turn comes. Okay, now without further ado, let us welcome our first presenter, Mr. Mario. He will present a paper titled Analyzing the Impacts of Dynamic Game Balancing in Survival Roguelike Chess Game. Please join me in giving a warm welcome to Mr. Mario. You have 10 minutes. Place and time are welcome.
Good afternoon, Miss. So I'll be sharing my screen first. Can it be seen?
Yeah.
All right. Excuse me while I take one screenshot for documentation purposes. All right. So let's begin. Okay. So good afternoon, everyone. My name is Mario. I and Miss Juliani Arifin are the authors of this paper entitled Analyzing the Impacts of Dynamic Game Balancing in a Survival Roguelike Chess Game. So the content list will be the introduction, followed by the related works, and then the methodology, finally the results. Let us begin with the introduction, where I will explain what is dynamic game balancing, the flow theory, and my research questions. Dynamic game balancing is simply a technique in video games where the difficulty of the gameplay will automatically adjust to the skill level of the player. We can see some reference by Mr. Mihaly and his flow theory, where as the skill of the player increases over time, the difficulty challenge of the game should also increase with it automatically. This keeps it in the flow channel and prevents it from being too easy and boring, nor too hard and frustrating. This approach is better than just the static difficulties of easy, medium, hard in improving player experience, which has been used in various games either for entertainment or educational purposes. Now for the research gap, as I've seen, dynamic game balancing for a hybrid genres, in which case will be chess and survival roguelike genres, is currently still underexplored in academic research. And therefore, this leads to my research questions. What DGB techniques are suitable for video games in the roguelike survival and chess genres? And how can user experience be enhanced through DGB, especially in roguelike survival and chess video games? Moving on to the related works, which are the existing research in DGB systems, entertainment versus serious games, and some real game examples in my genres. So more or less, when it comes to the studies in dynamic game balancing systems, their game prototypes involve first, players interacting with a computer game, either with just a standard keyboard and mouse, or sometimes with devices like a facial recognition system or some motion capture. Then, the inputs from the game, like their player HP, or the player itself, like such as their facial emotion, will be monitored by the game. And those data will be sent into some algorithms which will be used to estimate their player skill level or their player state. Are they calm or are they panic, for example? And those will be fed into some game variables which will impact the game difficulty. Will they become easier or harder? And this process keeps on looping the entire time. Oh, by the way, there are some alternative terminologies for dynamic game balancing, such as dynamic difficulty adjustment and automated content balancing, but they more or less refer to the same idea. Then there's some separation between some entertainment and serious games for dynamic game balancing. And here there's some research for entertainment games, such as in the genres of roguelike survival, shooter, horror, rhythm, adventure. There were also research where they modified existing games and added dynamic game balancing on top of them with good results, like Angry Birds, Minecraft, StarCraft, and so on. For the serious games genres, they've implemented for education, like strategic board games including chess, math, driving, programming, sometimes for rehabilitation, sometimes for exercise, and sometimes also for cognitive. As for the real game examples, there actually is some existing games that combine the chess genres and survival roguelike genres. For example, Shotgun King, Pawn Baron, Ouroboros King, and Chess Survivors. Unfortunately, one disadvantage of all of those aforementioned games is that they currently do not have dynamic game balancing. They all have static game balancing where players will determine a difficulty level at the start, and then after that, there's no more adaptation in the difficulty level, which brings me back again to my research gap and research questions. Fine, the methodology, where I will discuss about the study process game design, the calculations of the GB system, and the gameplay data and analysis. Before I actually developed my game, I went through with some preliminary surveys asking about the people's age, gender, their favorite genres, their perceived skill, their understanding of dynamic game balancing. What do they think are good methods to assess player skill? What do they think are good methods to change difficulties of a game? What do they think are good genres for dynamic game balancing? And how many people will be willing to playtest my game? And from those answers, I eventually decided to make a game in Unity, which will be a two-dimensional turn-based game, slightly partially reminiscent of chess, but with some added survival roguelike mechanics like health and power-ups. There are the DGB inputs and outputs. Inputs in here are the ways to measure player skill, and outputs are the way to change the gameplay difficulty. In which case, I have 4 inputs: damage received and dealt over time, their current health point, their power-up usage, and the time needed to think and move efficiently. They all have their initial values, where 1 is maximum and 0 is minimum. They are increased and decreased by different things that can happen throughout the gameplay, and they will be used to determine the DGB output number from 0 to 1, which will impact that enemy health attack quantity variance, their visual hints, the quality and price of power-ups, their movement AIs, and the time limit for every move, which will be then be fed into all of those DGB input numbers will be fed into an array director and will return a number that will be used by all those DGB outputs I mentioned. What will the formula be? It is a weighted linear combination, which simply put combines all of this, adds a weighting to them, and then returns the one value which will be used on all the DGB outputs. Why am I using this? Well, there are some advantages. It is first transparent and have irreproducible changes. It has lower computational overhead, which is useful in preventing lag for my fast-paced game. And there is lack of evidence for a relatively better DGB input, so I cannot say that this input is better than this input and deserves a better weighting, hence why I'm using an equal weighting for all of them. Then I will have each player play 7 different playthroughs. First playthrough with no DGB outputs, 5 games with 1 DGB output activated at a time, and 1 more with all activated. Every one of these will be compared against the first playthrough of static game balancing with a Shapiro-Wilk test. If it is saying that it's normally distributed, I will use the two-sample Wilk t-test. If not, I will use the Wilcoxon-Sign rank test to determine the differences with playthrough 1 versus every other playthrough. Is there a significant difference or not? And then finally, the results. I will show some gameplay development proofs, some preliminary testing results, and some of my concluding thoughts. First, this game prototype has actually already been finished with Unity and has gone through several iterations and feedbacks to make sure that the game balance is better and has a bug-free gameplay experience. So for example, on the left, you can see here are some of my UI designs for the main menu, the difficulty selection, the how to play section, and the settings page. And then on the right, this is the battle gameplay where they can, the starting page, the actual battle page, and then after every round, they can go to shop to buy some power-ups. And finally, when their health reaches 0, it is game over. Here's a more visual explanation of every DGB output. The top row means the players are less skilled and therefore easier gameplay. Bottom row means the players are more skilled and therefore harder gameplay. So less skilled players will get fewer and weaker enemies. Better players will get more and stronger enemies. Weaker players will have these red and yellow tiles that indicate where enemies will move next, whereas for better players, those hints gradually fade away or become completely invincible. And then for the power-ups, the weaker players get good prices, lower cooldown, and better damage, whereas for the better players, those power-ups will be degraded in their quality. And then for weaker players, the AI of the pieces are weakened. In that case, for example, it will move to a tile that can be easily attacked by the player or sometimes miss the player completely. But as the player becomes better, the enemies become smarter. They know how to move towards the player and avoid tiles that the player can attack them. And finally, for the time, weaker players get more time limit to decide their next move, up to 5 seconds, whereas the more experienced players will have a more shorter time limit, up to 1.5 seconds minimum to make their decisions. And here are some preliminary testing results from my gameplay where I've recruited 14 beta testers in my preliminary gameplay testing. And then what I used was the user experience questionnaire from the preliminary testing, where in this case, a mean score of 0.8 or above indicates a positive evaluation in which I got for all of these scales except for novelty. A part of this will be because my 14 beta testers, most of them have played a lot of.
Okay, sorry, Mr. Mario. Presentation times is up.
Oh, okay.
Okay. Thank you, Mr. Mario, for that insightful presentation. We will now open the floor for questions. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question.
Mhm.
All right, if there are no questions, I would like to ask a questions.
Mhm.
Okay. What are the main challenge in implementing DGB in games that have strategic elements like chess?
Uh,
Mr. Mario,
uh,
okay.
oh yeah, sorry.
Will you like address this?
Yes, I would like to try to address that. So, what are the challenges in designing a dynamic game balancing for a game with chess elements, right? Yes. So part of the challenges is, for example, I have seen some other people done dynamic game balancing in other genres. For example, uh, they have done for other roguelike gameplays where, for example, a person has a fixed health bar and they can use WASD to move freely. Whereas in chess, it's more restrictive. That's part of the challenge because in chess-related genres, we have to follow the rule that the gameplay must be turn-based and every piece only has a very limited number of ways in which they can move. Not like in some games where they like platformer games where they are able to move very freely. They can every millisecond of their movement has a difference in how they will end up winning or losing. Whereas in chess, yeah, part of what makes it challenging is that it is restrictive and extremely rule based. And part of the difficulty in designing dynamic game balancing comes from trying to make a gameplay over those strict turn-based rules while still maintaining a flow that it can be harder for good players while easier for weaker players.
Okay. Thank you, Mr. Mario. Does anyone have any question?
Yes, I would like to also make a question.
Okay.
Okay, go ahead.
What kind of model do you use for building the DGP solution?
What kind of model? Well, as for the model, it's simply some, you can say, a heuristic or rule-based coding in the Unity C# programming environment, where basically uh, combining with these rules as the players play the game over time, each one of these DGB inputs is constantly being monitored every turn, and every time they make a move, these numbers will change over time. For example, if they take damage, this value will decrease, and that will immediately impact what will be the mathematical output from this formula, and that output will then be used to impact all of these DGB outputs, where a higher number indicates a better player and therefore a harder gameplay.
Okay, thank you.
Okay.
Okay, due to time constraint, we must move on. If you have additional question, we encourage you to approach Mr. Mario during the break session. Let us now proceed to our next presenter. Please welcome Mr. Ida Bagus Indra Budi Kusuma, who will present a paper titled Utilizing CTAT Cognitive Tutor for Fraction Multiplication and Division with Adaptive Feedback. A warm round of applause for Mr. Ida Bagus Indra Budi Kusuma. You have 10 minutes. Place and time are welcome.
Oh, okay. Thank you for thank you for the time. Well, greetings, ladies and gentlemen. Thank you for being here and thank you for the time. My name is Ida Bagus Indra Budi Kusuma. As representative for this study, me and the others, Mrs. Salim Eliana and Mrs. Dadi Nurjana, have done this study entitled Utilizing CTAT Cognitive Tutor for Learning Fraction Multiplication and Division with Adaptive Feedback. So in this session, we divide the session into 4 sections, which are introduction that will include motivation and contributions of our work. Next, the method we use in the study, results that we have achieved, and conclusion about the study. So the first challenge is that students tend to struggle to understand fractions. This struggle is caused by a natural number bias, a condition when the students often tend to use the concept of natural numbers to interpret rational numbers and fractions. The second challenge is that the ITS development in math education only accounted for 15.4% of all ITS research. This shows that the development of math ITS is still in its infancy. There was also a gap in that some previous math ITS lack support for adaptive feedback. Therefore, our contribution in here is to make adaptive feedback for students in our ITS. Jump to the methodology that we used. We used the common ITS architecture as on the figure on the left. There are 4 modules. There are interface, tutor, domain, and student model used in this research. The system was developed using the cognitive tutor authoring tools, and we used the cognitive tutor to create the tutor, and then we deploy this web-based ITS into a VPS with an Apache as the web server. We proposed 4 knowledges that covered in this ITS. There were fraction with fraction multiplication, and then fraction with fraction division, whole number with fraction multiplication, and whole number with fraction division in here. So the interface was built with CTAT HTML editor, and each interface has 4 main parts, as you can see on the middle figure. The first part shows the problem definition by the system, and the number for the question is randomly generated from 1 to 10. And then the second part shows the rewrite problem, multiplication or division result, and then the model section. And the third part shows the simplified fraction sections, but in the study, we do not cover mixed fractions. And the fourth part, the last one, there are some buttons like go to homepage button to choose another tutor, new question to generate a new question, and then also hint widget in there. For the domain model itself, we have 3 kinds of model that will be used in the system. The model that used in the fraction with fraction division is also the same for the whole number with fraction division. This model will help students on solving the problem. For example, on the left figure, we utilize the CTAT table to model the multiplication of fractions with fractions in the form of A over B multiplied with C over D. First, the table colors the first column as the starting point for A over B. Next, the table colors the first row as the starting point for C over D. Both fractions colors will overlap to show the numerator, which A times C, and the model will color the uncolored cell after overlapping the fraction to show the denominator, which B times D. Furthermore, for our tutor model, we're responsible for providing the interactive dialogue with the students through hints, bug notification, or feedback. As you can see on the tutoring flow figure, the students will input their answer in certain steps, and then the CTAT JavaScript tracer model will check whether the students answer the correct rule or the buggy rule. And then if the students once answer the step incorrectly, the tutor will provoke a cognitive conflict through the dialog box. The middle figure shows an example of the feedback that at the first incorrect answer on simplifying a fraction step. It will try to notice the students that they had made an error, and then provoke a cognitive conflict by reminding the student that a simplified fraction is a fraction where they cannot divide the numerator and denominator by the same number except for 1. And then, however, if the student again answer the step incorrectly, then the tutor will provide an adequate solution for the current step. When the student solves the step correctly, the system will provide positive feedback in the form of praise and encourage the student to do the next step, such as "Great job, let's jump to the next step," or "Yay, you made it. Let's calculate the result of the fraction multiplication," and other kind of short positive feedbacks. The student model in our ITS will record the student's error and answer on current step, while for the participants, we divide our participants into groups, 14 students in control group and experimental group. We were helped by the teacher to divide the students equally. We conduct our experiment with this learning scenario. So the students did the pre-test first and they had intervention. The experimental group will use the math ITS instruction as additional, while the control group only received traditional classroom instruction. After the intervention, the students had the post-test and both pre and post-test consist of 20 number of questions, 5 number for each category of material included in the system. Oh yeah, one other thing, the experimental group will also had to fill the user usability and experience survey. We then use the pre and post-test score to get the statistical results of our preliminary study. As on the table 3, the learning gain of experimental group is 12.07%, almost 3 times the learning gain average of the control group. To see whether these results have significance on pre and post-test of each group, we then use the sample t-test for both control and experimental group. Both group has significance result on each pre and post test, as you can see on table 4 and table 5. Both have a p-value less than 0.05, but however, the experimental group still outperformed the significance of the control group. It has bigger means and t-value than the control group. On the table 6, the p-value for the independent samples t-test has p-value of 0.004, which indicates that there is statistically significant difference between the two groups. For the survey, each number on the figure represents the items on table 2 that the students were asked for. For each item, generally it has more than 60% with total of agree and strongly agree, which suggests positive response. But however, there were also students who answered disagree and strongly disagree on some items. For example, for the item number 7 and number 8 about the feedbacks, we found out that some of the feedbacks that we use in the system still need improvements, since some of them is just need to be adjusted better for the elementary school children, so they could understand better the feedback when they made some errors. So we could conclude that the math ITS could significantly improve the students' performance with a learning gain percentage of 12.07%. And the survey suggests that the students generally had positive perceptions of our math ITS. However, there are some spaces for improvements, such as expanding the materials that the system does not cover, and then adding some advanced features like data logging for further analysis, or gamification to improve the student satisfaction, and conducting a larger testing scenario to increase its generality. Well, I think that's all, ladies and gentlemen. Thank you for your attention and have a good day. Return back to the moderator. Thank you. If there's any questions that would like to ask you may open your microphone if they would may.
Perhaps I could ask a question then.
Yes, please. Since I think the moderator has bad connection, so you could,
Oh, okay.
I guess.
So perhaps from what I remembered, I saw that your math system could visualize multiplication and division of fractions in some sort of rectangular format, right?
Yeah, let me present it to you first. Like this one?
I saw some animations like that.
Yeah,
Yes.
this one.
I'd like to ask, does this also happen to teach addition and subtraction of fractions?
Pardon me?
Does this system also teach students addition and subtraction of fractions?
Oh, no, it is only covered the fraction multiplication and the division.
Okay, well then in that case, if you were to extend this to the addition and subtraction of fractions, how would you try to implement it?
Well, actually, for the addition and subtraction itself, there are some research had already conduct the study, and they also use the cognitive tutor altering tools to make the system. But furthermore, if we would like, if there's any other research that would like to combine this these two material into one tutor, it would be great through there are some way that the future research could future study could conduct and to combine this tutor, that they could upload this into a web-based, or they could use the cognitive tutor authoring tools data logging and their web-based ITS on their official website, something like that.
Well, all right. Thank you, sir.
Okay, thank you so much, Mr. Mario.
Okay, thank you, Mr. Ida Bagus Indrabudi Kusuma. Due to time constraint, we must now move on. If you have additional question, we encourage you to approach Mr. Ida Bagus Indrabudi Kusuma during the break session. Okay, let us now proceed to our next presenter. Please welcome Mr. Justimanta Tarigan, who will present a paper titled Hell Game. Warm round of applause for Mr. Time are welcome.
Hello.
Okay.
Hello. Sorry, I have a microphone issue. Can you hear me clearly? Okay. Allow me to start my presentation. My name is Justimanta, and in this presentation, I will be, sorry, how to get rid of this. Okay. I will be presenting one of my work titled EduGym Postmortem Open Educational Resource for Educational Game. It is a project that I've been doing with my fellow researchers, Nikaston Jendratro, Anandini Muhdiantini and Elviawati Muisa Zamzami. Sorry. Postmortem analysis is the practice of analyzing a project development after its completion. It's a very common technique when we're developing something new or using new technology during development. And in this paper, our objective is to discuss our experience in developing EduGym. It's an educational brain training app focused on micro-learning via quiz session. And our discussion will be focused on the content development and how the open educational resource will tackle the content development issue. So OER is a concept to provide educational material freely available to the public. It's available for use, revise, remix, and redistribute. The concept offers a new opportunity to reduce the cost of content development, allowing developer to access open data and focus on gameplay and game mechanic. And this is a very huge issue in educational game development, because educational game development mostly rely on the content. And of course, the issue of using OER is there's lots of AER, and using various resources of OER and lack of standard make it hard to align to the gameplay and game mechanic and difficulty adjustment. So we decided to develop our own OER using our own API, and by using this our self-built content OER, we are able to align the OER to fit our gameplay mechanic. So a little bit about the EduGym. It's part of the Edu Project program. Edu Project is a research focused on integrated reward mechanism between educational and recreational game. So the idea is to enhance perceived value of reward in educational game by allowing it to be used as currency in entertainment game. Basically, what you know as a term, we usually call it microtransaction. The future objective is to develop an ecosystem where there's an exchange reward between educational game and entertainment game. This is an Edu shooter. This is the entertainment part of the game, where player can play in a top-down shooter game mechanic, and there's no educational aspect in this. It's purely for entertainment. And the EduGym part is the educational side of the Edu project, where it focus on micro-learning educational app, delivers small, concise, and easy to understand educational content for quick consumption. The app consists of various quiz-based activities that cover subjects of English, math, and science, designed for touch-based Android mobile devices. Each game session lasts 30 seconds with aim to complete 10 questions, allows multiple difficulty level with different coin-based reward integrated with Edu project. So this is a very screenshot of the game. This is the early phase of the Edu project. As of right now, the game is completely redesigned, but we haven't able to get chance to capture the project and put it on paper. So yeah, basically the gameplay is like this. There are multiple choices, mostly multiple choices, and the player have to select one of the correct option. There are 7 game modes, 3 modes for the mathematics, and 2 for the science, and 2 for English. Probably due to time constraint, I will focus on the game modes, the game quiz modes. So the main challenge is we have 7 game modes, and of course the problem is because of the game development lifecycle, we use Scrum-based methodology. We apply this iterative product development for flexibility. However, the side effect of iterative, it causes a very rapid change, mostly due to lack of experience in game dev, because most of the project partly done by the students and lecturer that they have no experience in game development. So we probably need to change a lot, because we need to find the best solution for our game mechanics. This is the problem too, because the content development will not able to follow these rapid changes, because content is content. They have to put it somehow, the content to fit our gameplay. So if we decided to change the gameplay, the content itself will have to be changed. And this has become a challenge. Software changes and content development should be independent. We try to separate the game development and the content development. The application of OER allows the content to be extracted from the open repository, separates the software and content development. So this is the architecture of the development of the EduGym, and the development itself relies on the top side of the diagram. As you notice, we have a documentation and standard that the OER helps for this content. And software developer will rely on the standard, so their game mechanic changes will always fit the content that provided by the content developer. So the pro of this design is we use OER. We are able to apply a modular design, reduce bottleneck and repetitiveness, collaboration through documentation and standard, less conflict and miscommunication during development, and content generation by educator instead of developer. Because of these standards are easy to follow, it's not we also able to hire some content developer that have no experience in game development to fill our content, and we provide a web-based web page for the educator to fill their content. The other pro is application changes with respect with available content provided by OER, allowing for expansion rather than structure change. Tweaking data is easy. So because of the content developer don't have access to the do not rely on the game development. When they're tweaking the data, it's very easy for them by accessing it to the OER platform. The cons, of course, app requires content communication with the server, introduce minor latency, but especially during startup, but we didn't notice this issue during our tests. The second cons is lack communication, cause conflict and late phase and major redesign, because in the end, because we heavily rely on the document that is established in the beginning of the phase, when we notice there's a problem in the late phase, for example, it is impossible to develop a multi-level quiz, we have to redesign the whole project, and this problem should be able to detect it at the earlier phase if we do not use the OER. So we also performed the usability test for EduGym. This is actually not related to the research paper, but it's interesting to see how the EduGym performance in the Edu project. So we invite 24 respondents. We let them play in the 7 days period, and this is the result from the telemetry data that we collect based on their activity. And we also perform a test, usability test, using mostly Likert scale questions and one open-ended question. And this is the result of the usability test. We are confident that our EduGym works properly because the average value has reached above the average, above normal. And of course, there's a lot of improvement that we need to do based on the open-ended question. So in conclusion, the paper discussed the post-mortem analysis of EduGym, educational game focused on micro-learning. The OER itself solves challenges in content development in educational game. We are able to loosely couple app and content development. Data openness allow parallel data creation. And in the future, we would like to integrate OER to other educational game. We are going to expand our educational game library, and most of this game, if not all of this game, will access the API. So we just develop the content once, and then all of the other game will be able to access it openly. And also we invite other developers if they want to use our OER to the API. I think that's all for my presentation. If you have any question, feel free to ask. I'd be happy to answer. Thank you.
Okay, thank you, Mr. Justimata Tarigan, for that insightful presentation. We will now open the floor for questions. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. All right, if there are no questions, I would like to ask a question.
Yes, okay.
Okay, how does the effectiveness of EduGym compare to other platform on providing educational games as a learning resource?
Well, we haven't measured that yet because our tests actually involve gamers instead of children that actually our target market. Basically, probably students from elementary schools. We haven't tested on that audience yet. In the future, we probably will do that kind of test. And basically, to answer your question, we have yet to understand how this EduGym is effective education tools for the students. But in the future, we are going to perform that kind of test.
Okay, thank you, Mr. Justimanta Tarigan. Does anyone have any more questions? Okay, due to time constraints, we must now move on. If you have additional questions, we encourage you to approach Mr. Justiman Tatarigan during the break session. And let us now proceed to our next presenter. Please welcome Mr. Dimitrios Sarafis, who will present a paper titled AI and Civic Engagement, a brief exploration of application and opportunities. A warm round of applause for Mr. Dimitrios Sarafis. You have 10 minutes, place and time are welcome.
Yes, hello from me too. So my name is Dimitris Sarafis, and I'm here on behalf of my company Projects, a company here in Greece. And I'm going to present you our paper called AI and Civic Engagement, the brief exploration of applications and opportunities. So starting with introduction, the definition of civic engagement actually refers to citizens actively participating in political, social, and communication and community decision-making processes. The problem with traditional civic engagement methods is that they fail to reach marginalized groups and they fail to adapt to modern communication trends. So that's where AI comes into play, which offers innovative solutions to these problems. And it does this by analyzing vast amounts of data and personalizing the interactions between citizens and the government. So the solution that AI offers is that it uses transformative capabilities to enhance how government and communities interact. So technologies and tools such as natural language processing, machine learning, and chatbots, they streamline the citizen feedback and they enable more effective governance. So in our study, we conducted a systematic literature review and we focused on publications between 2019 and 2024, mainly to catch the hype with artificial intelligence, the period that it mostly was active, the period that AI was mostly active in. And we analyzed research papers from platforms like Google Scholar in order to explore the applications of AI in civic engagement. And the focus areas were AI tools, AI tools where we try to identify challenges and address ethical issues. So from our research, the main domain areas of AI applications we found are the following. AI is mostly used in citizen participation platforms, where they analyze feedback, they identify trends, and support decision-making with tools like sentiment analysis. Another domain is the social media, where algorithms can monitor public discourse, goals, and sentiment, and detect misinformation to enhance public trust and policy responsiveness. Then there are smart cities, where AI optimizes urban services like traffic management and resource distribution. It's accessibility and inclusion, where AI-powered systems provide translation, assistive technologies, and speech-to-text tools to bridge participation gaps for marginalized communities. And finally, civic education, where AI can build personalized gamified platforms that promote awareness of public policies and social issues. So some characteristic examples from our research are the following. Tools used for sentiment analysis. BERT is actually an architecture of models, an architecture for AI models, which was used for sentiment analysis to classify citizen feedback into useful insights. So basically, some models were used for sentiment classification in order to provide this sentiment to the government, and which later was able to adjust its policies. Another very common use are AI chatbots, which are used to enhance engagement by simplifying access to public services, and they also foster the trust by providing efficient and instant communication with the authorities. Finally, a more modern approach are virtual reality platforms, which can create immersive environments for citizens to participate in urban planning and policy discussions. So the main benefits of this kind of solutions are that they enhance inclusivity by reaching diverse groups and providing accessibility solutions. And they also improve governance by offering real-time feedback, they enable transparent decision-making, and they foster the trust that we discussed before. And here's a table of the key findings. So I'm not going to mention all of them. I'm just going to focus in a very characteristic one, which is practically what we discussed before. It's about the main issue, which is
Sorry,
citizen
Mr. Demetrios
engagement.
Sarafis.
Excuse me?
The screen hasn't changed till on the first page.
We are still on the first page.
Yeah.
Okay. Uh, hmm. Okay, let me try to share it again. Can you see it now?
Okay. Okay.
Okay, so I'm going to move on from here, from the table. So yeah, one of the main civic issues is, of course, citizen engagement. And the main tools from AI that come into this issue to solve this issue are chatbots and virtual assistants. And as I said before, the main benefits are real-time interaction between the citizens and the public administration. And we also identified some challenges to each of for its AI application. And for this specific issue, the main challenge is the risk of misinformation or manipulation. And yeah, so here is an overview of the challenges in each kind of AI application. The first one is digital divide, which refers to the limited internet access and digital literacy in urban areas, for example, rural areas, which can restrict AI adoption. So without targeted efforts by the government, AI risks deepening existing socioeconomic divides rather than bridging them. Another challenge is the algorithmic bias, which is very common in all kinds of AI applications. And that is AI systems are trained on biased data, and they can preserve inequality, especially in marginalized communities. So addressing this bias requires diverse datasets, transparent models, and inclusive development. Another issue is transparent and trust. Citizens often lack confidence in the AI systems due to the non-clear decision-making processes. And open communication and explainable AI models are a key to build trust in these systems. Finally, it's privacy, which is mainly caused due to large-scale data collection that pose risk of breaches and misuse. So encryption and privacy-based frameworks are critical to solve this issue as well, to protecting citizen data. Some ethical considerations that were identified in our research are the following. Ethical considerations are crucial for the responsible implementation of AI civic engagement, and thus a human-centric design approach is necessary to ensure AI systems are aligned with the society needs. Second is developing fair and biased AI requires the use of diverse datasets and involvement from multidisciplinary and representative teams. Thus, AI applications must be built so that they follow democratic principles and do not reinforce inequality. Finally, ethical accountability is not only a technical challenge, but also a societal commitment, which needs collaborations among policymakers, technology companies, and civilians to create trustful AI solutions. Finally, future directions in this domain are the following. Human AI collaboration is the key to blending computational capabilities of these systems with human judgment, and this will help to create systems that are transparent, inclusive, and ethical. One of the most promising tools in the papers we deal with are the immersive technologies like virtual and augmented reality, which offer potential for engaging citizens in real-time interactive processings. Third, localized AI tools address the needs of marginalized populations, and they can help overcome barriers such as language and digital literacy. And finally, standardized policies and scalable architecture can enable widespread and equitable access and benefits for all citizens. So that's all for me. If you have any questions.
Okay, thank you, Mr. Dimitrios Sarafis, for that insightful presentation. We will now open the floor for questions. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. All right, if there are no questions, I would like to ask a question. What is the role of explainable AI in building public trust in AI-based system?
Yes, so the main problem with AI solutions is that they do not offer many insights into the way the system takes some decisions or the system makes some recommendations into any kind of problem, not only for civic engagement. And explainable AI can actually offer an insight into how these models take decisions or how these models generate the output. So it's a technology that is mainly used in, for example, health solutions, where we need to know how the model took a decision for the doctor to better trust the model and not just take it as a fact. And they can judge better whether the output was based on reasonable data and not just some not very reasonable data, actually. Yeah. So in this case, in civic engagement, it can also help to the citizens to better trust the model and see if the output was something reasonable and not something that came of from not much thinking of the model.
Okay. Okay, thank you, Mr. Dimitrios Sarafis. Does anyone have any more questions? Okay, due to time constraints, we must now move on. If you have additional questions, we encourage you to approach Mr. Dimitrios Sarafis during the break session. Okay, let us now proceed to our next presenter. Please welcome Mr. S.Kom Saputra, who will present a paper titled Evaluation of Diversity and Novelty of Recommendation System on Digital Learning Platform based on User Usability and Satisfaction. A warm round of applause for Mr. S.Kom Saputra. You have 10 minutes. Place and time are welcome.
Oke. Assalamualaikum warahmatullahi wabarakatuh. So, good afternoon, everyone. Thank you for attending this meeting and giving a time. for me to present my research with the title Evaluation of Diversity and Novelty of Recommendation System on Digital Learning Platform Based on User Usability and Satisfaction. So let me introduce myself. My name is Ilsam Rapsutra as author one, and the second author is Mr. Dana Solistyo Kusumo. Okay, let's begin. My content list in this presentation, the first is introduction, the second is research method, the third is evaluation and analysis, and the fourth is conclusion and future work. Okay, the first introduction, next. So my background for this research is because there is a Statista data report in 2024. There is a in this digital learning platform, there is global user rising from 746 million in 2022 into 800 million in 2023. So, and then there's so
Sorry,
many
Mr. Elsa.
platforms as Duolingo, Udemy, and Ranguru, and have so many platforms using a system
Mr.
recommendation.
Elsa. Sorry, the presentation is not showing.
Okay, I'm sorry. So my background from this research is about the rising of global user in the digital learning platform from 746 million in 2022 into 800,000 million in 2023. So there is so much digital learning platform like Duolingo, Udemy, and Guru has using system recommendation to help the user to find their goal or achievement to get learning material that he likes or they likes. So what is the problem? So what is the problem? The problem is there is so much amount of available content that available in this digital learning platform, and the second is the difference in individual user preference, and the third is the system recommendation. In the traditional system recommendation primarily focus on accuracy. So this is a problem because we cannot get or we can give the exact goal for user in this digital learning platform. So what is the aim of the research? In this research, we take a primary factor, different factor from the accuracy. So there is a diversity and novelty. So diversity and novelty is not using accuracy as the metrics. So this will be trying to be get a satisfaction and usability in digital learning platform for the user. Next, so how we assess the goals or achievement? So the first we are using recommendation system metrics such as intra-list diversity for the diversity and mean self information for the novelty. And the second is we gather user feedback through questionnaire survey using Likert scale. And the third, from the user feedback, we analyze based on the research question 1 and the research question 2. Okay, let's begin in the research method. Okay, there is 4 research method process in this development of system recommendation for using novelty and diversity, and the first is data collection and data preprocessing. So in the data preprocessing step, we using a scaffolding, and then we use data cleaning, and because we get the dataset from Kaggle online course dataset, there is 10,000 row in this dataset, but not all of the data is clean enough. So we use for the important data, we use k-nearest neighbor imputation for filling up the most important data that we will use in the application. And then after data preprocessing, the data only becomes 4,000 data and becomes only 14 features that are really important to develop. And the second is reduction of attributes that are not needed. So that's why the feature is only 14. And then the filling using Canary Snackboard, as I say before, and complete data, it will be sent it because this is we are using common clustering. This is unsupervised learning. We send the data into the database. Okay, and then we come to the system development. So the first is we are developing the front end development. We are using the authentication and personalization form. In the personalization form, we gather three until five genre or preference from the user. So we can get the recommendation still based on the preference but has a diversity and novelty. And then the third is API integration for a stable and good system. In the backend development from the dataset that has been processed before and loaded into the database, the course within the same class, how can we get the recommendation list? The recommendation list, as I said before, we use the
Hey,
preference
Mr. Alsan, please turn your on your camera.
Oh, I'm sorry. So I'm sorry. So let's about the backend development. So after that, we calculating the recommendation list using intra-list diversity and mean self information. So after the threshold got passed by the threshold ALD and MSI is passed by the recommendation list will be displayed in the front end and will be consumed by the user that use the digital learning platform. And next we come into the section evaluation and analysis. So as I said before, in the evaluation analysis, the first is we are calculating the comment clustering. Is it a good clustering or not using siloed score? So the highest score is 0.791 was achieved with 4 clusters. So we calculating we get the best cluster that we will use in the dataset. So we get the 4 cluster, and this metric is good because this metric is above 0.5 but below the 1 value. The second is we test the average of 45 participants in this research that we are testing the metric ILD and MSI based on the participant preference. So we got the ILD score is 0.61 and the MSI score is 0.62. So it's also same as like Silhouette score that it is above the 0.5. It's the recommendation list has already diversity and novelty in this recommendation. After that, we gather the user feedback using questionnaire survey, using Likert scale. We carried out the 45 active students who had currently using online digital learning platform e-learning. So there is a 10 question that give to the 45 active students. After that, we are going to research question analysis. The first is how does the intra-list diversity metric and means of information metric measure the diversity and novelty? As I said before, because the ILD and the MSI value is greater than 0.5, but it's not it's still below the 1 value. It means that the recommendation list or recommendation system has already using the preference but give also novelty and diversity in this recommendation list. And then how do we calculate the user satisfaction and usability related to the diversity and novelty aspect of this recommendation provided. So in the recommendation, this questionnaire, there is four, or we have using Likert scale, and the all mode and the median from this questionnaire is 4, and then the 4 is mean the user is agree. So it we can say that the all user is agree that the recommendation list has diversity and novelty really give the user satisfaction and usability. Okay, and the last is conclusion. So the conclusion is the evaluation results show ILD and MSI confirming the system ability to provide diverse and novel suggestion, and user satisfaction and user usability give positive feedback because there is median and mode have all user agree that the user satisfaction and usability is confirming by the recommendation list. For the future work, we should explore more about the user data because this is
Sorry,
just...
Mr. Elsam, presentation times is up.
Okay, thank you for the time. Is there any question?
Okay, thank you, Mr. Elsam, for that insightful presentation. We will now open the floor for question. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. Okay, if there are no questions, I would like to ask a questions. Um, okay, Mr. Elsam, why is Kinner Snake more or ENN imputation used in the data processing stage?
I'm sorry, can you repeat the question?
Yeah, why is key nearest neighbor or KNN imputation used in the data preprocessing stage?
Oh, okay. Thank you for the question. I'm using the Curious Network because I'm cited by the other same research, but so there is no research about the learning platform, but there is so much research about the movie, the songs, and the others. I cited because I'm also using the Kamin clustering, so I said that from the other research that some of the suitable method that for filling up the NR null value is good using the Canary network.
Okay, thank you, Mr. Elsam. Does anyone have any more questions?